All right, so Prof, you can continue.
Okay. Sharing, please.
Okay, all right, just a minute. All right, you should be able to do so now.
Thank you. Okay, all right. Good evening, good morning, good night, everywhere you are. Good period. I trust we are all doing well.
Yes,
Thank
please,
you.
we are doing great. Thank you.
Thank you for coming. It's always another form of experience to meet people who want to learn, because then it means that they are ready to things that they share. Okay, before I continue, sorry for the delay. I was caught up in a fix, but thank God I was able to come up before everything got so late. All right, so if you have any questions on what we've done so far, some ideas, something that keeps bothering you, please just feel free to ask. It's all about the Arduino and the fundamentals. So any questions from yesterday, any questions from tomorrow, any questions from the past years, you can please ask. Okay, all right. So yesterday we started talking about the fundamentals of Arduino. We made mention of the fact, for the sake of those who are joining today, I'm Mr. Obeng, and I'm pleased to be your tutor today. Teaching and learning are the same thing, because both the teacher and the student learn from each other, just that one talks more, and I happen to be the one to talk more today. So thank you for coming. Okay, so we talked about the Arduino, the type of Arduinos that we have, that various families, what to choose for your project. We did a little bit of how embedded systems is analogous to the human system. And I did mention that there is something called biomimicry, which is a way to emulate something that exists in nature when you are trying to solve human problems. So that is something I do so much. Anytime I have to model something complex, I try to find out, is there a way, or is there something similar in nature? How does nature do it? Then I always learn from nature. So you can always read from that. So I did all these things as a form of showing you that embedded system is actually not too far from you, because the human body and the way we build systems to function, which in this case we are trying to use the Arduino for, are quite similar. So we can always have some form of motivation from it. Okay. And we talked about Arduino as a platform. I mentioned that the platform is a combination of hardware and a software, but right now we all have what we call the software-only platforms. And yeah, talked about Arduino as open source, what that means, why you should be using Arduino, the various Arduino families, which of them to choose for what project. We talked about the types of microcontrollers present on a genuine Arduino, and some of the features that they have. So I think we got to the pins, I think. Yes. We got to the digital pins, and I was talking about what do we call it? I was talking about communication protocols, then I ended. So if you have any questions up to this point, please feel free to ask. Yeah, any questions? Okay, so let's hope all is well. Now, yesterday I did mention that the Arduino board, there is a pin called RST, which is actually connected to the reset button here. So over here, we have the reset button, and it is connected to a reset pin. And I did explain that when you embed this Arduino in a project, you wouldn't get the chance to be pushing directly on this reset button. So they made it possible for you to interface your own reset button so that you can connect that one outside. Probably you are packaging the project in something, so you can have your own reset button that can function just like the reset button that we have on the board. So I'm going to show you how to connect the reset button to the Arduino. And I think today the practicals will start directly. Now, technically, I wanted to use Tinker, which is an online platform, but then my internet is not very great at the moment. So I'm going to use Proteus for the simulations, but basically it's the same thing. I actually prefer the Proteus because you get to learn both newbie stuff and also the actual way things are done. So I have a simulation here. I want to show you how to connect an external button to control or reset your Arduino. So if you know how to use Proteus, then you probably have seen this. If you don't, please don't worry. Tinker is very intuitive and it's something that you can easily find your way out. Okay, but if you really want to do electronics, trust me, this should be your thing. Okay, so I have an Arduino. So over here, I've connected to the reset pin. There is a push button here. Okay, and now internally this reset pin is connected to 5 volts. Okay, internally on the Arduino board. Now over here I have also connected it to 5 volts. Technically I'm not supposed to do this because there is already an internally pulled up 5 volts, but I wanted to show you something. The reset pin is used in a state called active low. When we say that a signal is active low, so if you look at the reset, you can see that there is a bar on it. The bar shows you that this gets activated by a low signal. So it means that by default, the reset pin is supposed to be high, okay? So the moment you pull it low, you connect it to a ground. That's what I mean by pulling it low. Then you activate the reset sequence. Is that okay? So in order to pull this low, we have to find a way of connecting it to ground when we press the button. So we use a very simple technique. So over here, I have a button and I have a resistor. I can actually take away this resistor and connect this point directly to 5 volts, which will do well because internally, this particular reset pin is having a very high input impedance. So technically or theoretically, no current is supposed to pass through, but then that is not in real time, that is not accurate because no matter what, some amount of current, no matter how small it is going to flow through. But one thing you should know is that it is having a very high input impedance, okay? But then if I take off, for instance, let's say I take off this particular resistor and connect directly like this. So far as this switch is open, everything will work well, okay? But the problem is that the moment I close this switch, we will now have a short circuit between 5 volts and ground. And you know what short circuits can do, which is so not ideal for any circuit, okay? So in order to prevent the short circuit, that is the reason we put in a very large resistor here, because technically we don't need current flowing through here, okay? Now, ideally, you can make this as huge as possible, but usually I just throw in a 10K and that does the magic for me. So this 10K makes it possible such that if I close this circuit, we don't have a short circuit on this line, okay? So I'm going to simulate this. Now, yesterday I mentioned that Arduino has 2 protective features. It has what we call the power on reset and brownout detection, okay? And I said that the power on reset makes the Arduino reset anytime you connect power to it, okay? So that means if I also pull this reset pin low and I reset the Arduino, it should start the execution. Now, in the Arduino I've written a program that blinks on, off, on, and off. But when it is starting, the blink sequence is quite different from when it is in normal execution. So let's look at how things work. Let's run this. I hope fatal error. What is happening here? Okay, let me see. Oh, okay. Yeah, my bad. I have to link my Arduino to, was this thing correct? Let me do some calculation. Okay, and then, oh, come on. I always prefer physical meetings when I'm doing these things. All right, so I'm compiling the sketch. If you don't understand the code here, don't worry. After the day, you would know what these things mean. Okay, so compiling, and then I have to close down some applications. Okay, so the program is compiled. Now I just have to link my output program to my Arduino. So let me copy this hex file. Come on. Okay. Copy this hex file. Then link it. Don't worry about what I'm doing. You get to understand. Okay, so we have our hex file here. Now that Arduino is linked. Okay, so let's execute. Okay, so you can see that the LED here is blinking now. It is just responding to the program that I wrote. Okay, just like an actual Arduino. Again, this LED is connected to pin 13. So even if you are following, you can just run the code, and on your normal Arduino, you should see the board LED on the board blink. Okay, now look at what happens when I press the reset button. You see that the whole program started again. Now let me show you the program. When inside the program, I said that when it starts, it should turn on for 75 milliseconds, off for 50 milliseconds, and repeat the cycle 10 times. Okay, so that is why when I reset it, we have that kind of blinking, yes, before the actual execution proceeds. So this is showing you that the reset button is actually happening. Now, anytime you connect a button this way, okay, so that when you press on the button, it sets a low voltage, we say that this is an active low connection. An active low connection. Now, if you want an active high connection, all you have to do is to swap the position of the button and the reset and the resistor. Okay. So if you look at this, before pressing the button, we have 5 volts here because technically there is no current flowing, right? But when I press the button, then it goes to 0 volts, meaning that it is linked to the ground. That is why our Arduino is resetted. So in case you connect your own microcontroller, let's say you remove the Arduino's microcontroller for your work, or you want to find a means of restarting your Arduino in the project, this is how you do it. Very, very simple. Okay, any questions? Any questions on this? Today we'll be switching between this and that very often, so just bear with me. Right, any questions? Yes, any questions? Any questions? Please let me hear you. Let me hear from you. I want this to be an interactive session so that I can know exactly what to give you. All right, so let's continue from where we ended.
Okay, so Prof, can you hear me?
Yes, I can hear you.
So I think there seemed to be a question in the chat earlier on. So Elijah says, could you please elaborate once more on the RX, TX, and its effect on using the USB together? Sorry for the noise in my background.
Sure. Okay, so thank you. Let me take that again. I'll be talking about that in no time, so maybe, yeah. Okay, so all this we spoke about yesterday. Okay. All right, so communication protocols. So the one who asked the question, I would mention that I'll talk about it here, okay? So the Arduino is capable of 3 main communication protocols. When we talk about communication protocol, it's a means that Arduino communicates with other devices, okay? And basically, we have what we call the UART or USAT. USAT stands for Universal Synchronous Asynchronous Receiver Transmitter. So the UART happens to be a subsection of the USAT, okay? There are some devices that operate on the USAT and some that are UART. So if something is USAT, it means it can operate as in a synchronous or asynchronous manner, okay? Synchronous means it is timed, something, it has to be timed. Asynchronous means the communication has to proceed without any timing. The system is able to detect the start and the stop of the communication. All right. Now, let's take something like a GSM module. You want to interface the GSM module to Arduino. GSM modules are usually communicating with Arduino via UART. Okay, so if you've used Uno before, probably you've heard of what we call the software serial or serial communication. Usually when you are performing serial communications, you are using the UART or serial means of what? Communication. Now, in the UART communication, 2 pins are being used. And on the Arduino, these are pins 0 and 1. So if you look on an Arduino, you realize that pin 0 is labeled RX and pin 1 is labeled TX. Technically, take it as this. The RX is the receiver pin. So if as I'm speaking with you right now, when I speak, your ear listens, right? So my mouth speaks or delivers the message, your ear listens to the message. So to me, when I am the one speaking, so I'm TXing, right? And since you are the one listening, you are RXing. Okay, so my mouth is connected to your ears and your ears connected to my mouth. So that is how the UART communication proceeds. The RX of one device connect to the TX of the other, and the TX of the other connect to the RX. So that is it. Now, the reason I said that don't use this TX and RX pin, from what I've experienced, anytime you connect them to maybe something else in your circuit, when you try to upload code via the USB, it doesn't work. Okay, you will have to remove the Arduino from your circuit, connect it to the back in a project, and it's packaged. You don't want that kind of thing. Like you always have to remove your Arduino from the project, load your code before you insert it. This is because when you do that, there is conflict between the USB and your what do you call it, your circuitry. Okay, so something causes the voltage drop and the Arduino is unable to listen to the communication from your USB port wall. So from what I've seen, anytime I have done that previously, my USB doesn't connect to the Arduino, or I'm unable to load code to the Arduino unless I remove the Arduino from the computer. Okay, so since then, since I detected that like some years ago, I never use my UART pins, which is the RS and TS, for anything. Even when I don't need, I need more pins, I make sure I don't touch it. So I don't know, the one who asked the question, whether that is okay. It is to avoid when you use it, it conflicts with the USB when you are loading program. But of course, the the USB is not the only means of loading code onto the Arduino. You can also use what we call the Icsp header. Okay, and this is, those who don't know, this is the Icsp header. Okay, so you can also use this as a means of loading code onto your Arduino instead of the USB. However, if you use this guy here, you can't have access to serial communication, as in you cannot have the serial print line between your computer and the Arduino. So if you want to have such a thing, then you would have to be using the USB. And that is the reason you don't want to connect these pins, okay? You don't want to connect this pin. Now, sometimes I think if you even connect just one of them, sometimes your system may work, but just avoid any hassle and then avoid using these two guys. That's all. Okay. All right. So if somebody asks any question, please, you can always draw my attention. Okay. So for UART communication to proceed, both devices should be capable of UART, and like I said, you connect RX of one to the TX of another and TX of the other to the RX. So the same way, the same thing happens when you are communicating between your computer and your Arduino. Okay, so the USB ports in the computer, the USB port, they have some signals called D+ and D-. Okay, so the D+ and D- connect together, and there is a shift over. That is actually what the Atmega 16 does. It's the one that controls, it serves as the bridge controller for the USB communication to serial. Okay, so for some Arduino clones, you get ICs like CH340 or FTDI programmers. Okay, but for the genuine Arduinos, they use the Atmega 16U, as I talked about yesterday for that. Now, Arduino Uno has just one hardware serial. When you talk of hardware serial, there's a serial communication that is actually controlled by an IC, okay? And that is the hardware serial. And that is what happens when you use pins 0 and 1 for serial communication. You are using hardware serial. But then there are times that you have a lot of devices that you want to be able to communicate with the Arduino, and they may be communicating via serial. So the Arduino platform has a software version of the serial, which they implemented using a technique called bit banging. Okay, so it mimics the hardware serial, but it's just a software way of implementing the hardware serial. So to do that, there is a library in Arduino that comes by default called software serial, and you can use it to connect, make serial connections using any of the other digital pins to connect serially to other devices. Okay, but then even if you connect 10 devices serially, okay, if you connect 10 devices via UART, you can only talk with one device at a time. You can't push data to all of them at the same time. At every point in time, the Arduino can talk to with just one. So it has to be like you select a particular serial port, you communicate with it, select the next, communicate with it, okay? But then you can have multiple of them connected to Arduino at the same time, but the communication has to be one after the other. So this is a diagram representing how serial UART communication proceed. One, the first IC, the second IC, or the first device, second device, TX, RX, TX, RX, and that is how you always have to proceed. And then, of course, you should always make sure the two devices are connected by ground. Even if they have different power supplies, their ground have to be connected together. Anytime you connect two circuits together or two devices together, you should make sure their grounds are connected together. So that's the UART. Then the second communication protocol is the I2C or I2C. You see, the problem with UART is that anytime you connect a UART device, you are making use of two Arduino pins, right? So for a typical Uno, which has 13 or which has 14 digital pins, if I connect just 7 UART devices, I'll be out of pins unless I probably convert the analog pins into digital pins, right? So UART devices take too much pin. So they had to come up with other protocols, because there are times where you can connect to a lot of sensors, and all these sensors need to communicate with Arduino via a certain protocol, right? So they came up with the I2C. Now the I2C for Arduino, it's an 8-bit address system. So that means that 2 raised to the power 8, right? That should give you, 2 raised to the power 7, sorry. That should give you 128. So for I2C, it makes it possible to communicate with as many as 128 devices at a time. Technically not at a time, as you can talk to all of them at a time, but it gives you the abilities to connect up to 120 devices to the Arduino and speak to them one after the other. That means you can actually create an Arduino supercomputer by just joining many Arduinos together via an I2C, okay? And take note that all these communication protocols are supposed to take place over relatively shorter distances, okay? Relatively shorter distances. The more the distance, things begin to go weird. The frequency at which the communication is proceeding, all these things have to be factored in, because the longer your cable, the longer what we call cable capacitance signals tend to be attenuated and all that. Okay, so when we talk about these protocols, we are looking at very short distances, not the Ethernet cable form of communication where you can proceed over very long distances. Okay, all right. So the I2C, like I said, uses address system and 8-bit address system, and that makes it possible to connect 128 slave devices to the Arduino so that the Arduino can communicate with it. Now, if you've used something like an RTC module before to provide clock and time for your Arduino, you realize that you are always connecting it to the SDA, okay, and you use an address. Now, typical I2Cs, I think, usually use 0x68 address, okay, usually, but some of them are configurable. You can always change them. And there is this LCD with a backpack, okay, so the backpack makes it possible to communicate with it on the I2C line. So the main advantage of the I2C is the fact that we're able to connect many devices to the Arduino at a time, okay, without using pins. You see, if I even connect 100 devices to the Arduino via I2C, I will still be using just the 2 pins because it's a shared bus. Okay, we have the SDA and the SCL, which on the Arduino Uno would be A4 and A5 lines, and all your other devices just connect on this same line. Okay, they don't have to take any extra pins. So this is why this I2C communication protocol is great. Connect many things and still use only 2 pins. All right. Then we also have the SPI communication. Now, the SPI is by far the fastest communication protocol on the Arduino board. Now, all these 3 communications protocols that I've talked about, they also have their speed limit. SPI is the highest, followed by the I2C, and then UART is the slowest, okay? Now, whenever you use an SPI, it also has a shared bus, all right? But it also comes with pin expenditure. First of all, you will need 3 pins to share. 1 pin for SCK, which we call the clock line. 1 pin for master out slave in, what is labeled as MOSI. Then we have master in slave out. Now, these are the 3 shared buses or shared lines. But then with the SPI communication, all the devices that you connect to the Arduino, you would have to activate it using what we call the chip select or slave select line. And all this selection is done using digital pins. So that means if I connect 4 Arduino pins at the SPI devices to my Arduino, I will assign the 3 shared SCK, MOISI, MISO pins. I will need 4 other digital pins to control them, okay? But then there comes to a point where you can only use SPI because some devices work so fast that you can't hook them up with I2C, you can't hook them up with UART. So they will require the speed of the SPI, okay? So most often, this is not something you choose. Usually the modules come with the communication protocols already embedded. The manufacturer of that module determines that, okay? But anytime you have the option of making the choice yourself, what you have to consider is what speed am I looking at? how many devices do I want to connect? How many pins do I have? Okay, so this is how you make the decision as to whether to go with UART, I2C, or SPI, okay? Aside the fact that mostly the devices you may want to connect already have a particular communication protocol that they use. So things like an SD card shield will always communicate over SPI because it requires quite a lot of speed. Okay. All right, so any questions up to this point? I can look at it before we continue. Any questions? Any questions?
Yes, hello.
Yeah.
If anybody has a question, please feel free to type it in the chat. We'll read it out for you. If you want to say, you can say it and we'll address you. However, I have a personal question myself.
Okay.
Among all these three communication protocol, is there one that you can do like it wirelessly, or all of them require USB connections to what you want to do with it?
Okay, so all these protocols are actually wired connections. They are not wireless. Wireless is another thing altogether. Okay, so the wireless communication, that you always need another form of interface like Zigbee or a Wi-Fi protocol, something, right? But these communication protocols that we are talking about, they are wired, so they need to be physically connected with cables. Yeah.
Okay, thank you very much, bro.
Please, any other questions? You see, usually I prefer to have this theory embedded so much because actually your ability, your ability to do the practicals depends on how much of this information you have, okay? If you don't know some of these fundamentals, it becomes difficult to even select these devices in the first place, okay? So please make sure you are grabbing this concept because it's out of this concept that we're doing everything that we are about to do. Okay, so if you have any questions, please feel free to ask. Okay, so there is a device that I've designed called Mabel, which I've been using to teach sessions on Arduino. Now, Mabel is just a device that sits on top of Arduino and adds circuitry to it for you to be able to easily learn how to program Arduino and also learn electronics, okay? So anybody who is curious about Mabel, you can talk to me later and then I can talk more about it to you, but this is just for your information. Okay, so thank you. The theory has ended. Now, second, so this particular slide was supposed to be for yesterday. So thank God I just completed it. So let's look at today's lecture. Give me a moment to bring that up. I hope I completed it. So if you have any questions, please feel free to ask. Yeah. Okay, all right, so let me bring this up. Okay, come on, master projecting. Okay, just a second. Yes, any questions, please feel free to ask. Feel free to ask all your questions, Okay, so that is actually every little thing, at least for now, that you need to know about the hardware itself, but there are other things that would come up as we look at the software aspect of the whole show. I think there is. Would there be any accuracy problem or errors when simulating online? Actually, no. So the simulation model should work fine. Yeah, I think the programmers have actually, they should have handled any expected form of errors. Yeah, I just don't like the breadboard stuff. Personally, I didn't do much breadboard in my life. I like to do the real deal, but for the newbies, you can learn, you can try to tinker with it, tinker. Okay, so let's look at the software aspects the software overview. So,
hi, Professor.
Yes, sir.
Your screen is showing us the preview session. So I think maybe you should check that.
It's showing me
it's showing us the preview for
okay.
PowerPoint. Yes. So please check.
Thank you very much. Swap. Good now, right?
Yes, Professor, sorry to interrupt. There is a question. There is a question from, I'm sorry if I spoil your name, it's Abhishek Kumar. He asking, maybe any accuracy problem or error while simulating online?
I think I just mentioned that. Okay, so the Tinker platform, I think whatever issues that needs to come up, okay, the developers have probably done that, okay, and of course it is a simulation, and since it's online, lags and latencies in your communication internet would actually pose some problem. I think yesterday when I tried to use it, there was a little bit of latency. I mean, the blink rate wasn't as okay, but it's a simulation, and it should just be fine. It's a means of just getting you to see what is going on. Okay, so most of the time you should be good. You should not worry about that. But if you can actually acquire a physical Arduino and tinker with it, I think that is the best experience you can have. Okay, or you can get a Babel too. Yeah, that was just by the way. All right, so. Okay, so the software, we said Arduino is a platform, right? So it comes with the hardware and the software. We just looked at the hardware, and I've actually mentioned the majority of the things that you need to know about it, the pins, the digital, whatever. But before we can actually do something relevant with it, we need to look at the software real quick, and then we can have some practicals, okay? So this that you are seeing right now is the Arduino IDE, okay? And IDE stands for Integrated Development Environment. Now, what this means is that we have various tools integrated as a whole so that your work as a developer becomes very, very easy, okay? So in this program, you have a place to input your source code. The source code is the command that you are writing for the computer to execute. And there is a place for you to compile, a place for you to upload it onto your Arduino. Everything has been put together. So all these various tools have been integrated. That's why we call it Integrated Development Environment, okay? All right, so Arduino's IDE is very, very simple. Now, the source codes of Arduino, the files that you'll be creating out of Arduino, we call them sketches. So if you look here, you can see that there's a sketch underscore then something, right? So an Arduino source file, which is a file containing Arduino source code, is called a sketch. It's called a sketch or a sketch file, okay? All right, now, just a quick overview of the UI. The UI, like I said, is very basic. Now, if you look at what is blinking here, is the new button, which we use to create new sketch files to write code, okay? And you can also access that same functionality when you go to the file menu. You can have file new, but this is a shortcut that allows you to do the same thing. Then from next to it is the open button. Let's say you've created a previous work and you want to open that work, you can use the open button. So it's intuitive, just like any other software. Then when you want to save your work, this is also a shortcut way of doing that, or Control S. And you can also access all these functionalities under the file menu. Then we also have what we call the serial monitor button, which is a way we are able to view data from the Arduino and also send data from the computer to the Arduino. So it makes it possible for us to have serial communication between the Arduino board and the computer that we are using to program. Okay, so when we say hello world from the Arduino, we can view it using the serial monitor. And when we can also send something to the Arduino to do something via the serial monitor, okay? So to launch the serial monitor, you use this at the serial monitor button to do it. And again, you can open it under tools. I will be going to the Arduino sketch very soon. Okay, now there are a few terms that you need to know, at least for the newbies in programming. Now, there is something you hear, these are things that you hear me say a lot. The first is source code. Now, a source code is the human readable computer instructions, the things that we are going to learn how to write. Okay, now one thing I need you to know is that the computer doesn't understand jack about the source code that you've written until it is compiled to a version called machine code. Okay, sorry. Until it's compiled to a version called the machine code. Okay, so the source code will mostly be in natural language like English, mostly be coding in English. So you see something like serial, which is an English word, print line, and all those. These are English stuff, right? So that is how we can understand it. So we write our commands in a form of source code. What we write is the source code, and the computer doesn't actually understand that source code. The source code is purely for us, the programmer. Okay. Now, when we write our source code, we save them on a hard drive in a file. So a file containing source code is what we call the source file. And for Arduino, it has a custom name called a sketch. Okay. Now, when you have a lot of a folder containing many sketch files, we call it a sketchbook. Okay, call it a sketchbook. And Arduino by default creates a sketchbook. Sorry, Arduino by default creates a sketchbook. Who is calling me? Please, sorry. Somebody is WhatsApp calling me. Sorry, do not disturb. Okay. Okay, thank you. Sorry for the interruption. Okay, so by default, whenever you install Arduino, it creates a folder on your system, in your document folder to be specific, where it keeps all the codes that you write with Arduino. Okay, so anytime you are trying to find out where did I save my thing, it's in your document directory. Okay, but you can actually change it and save it anywhere you want. Okay, then you also hear of libraries. Now, libraries are codes that have already been written by other people that you borrow to add your own code to make certain functionalities possible. Okay, so depending on what we are doing, we may need certain libraries. Okay, so libraries are just codes that have been written by other people. Some of them come already bundled with Arduino, but there are also times that will depend on the internet, what people have done to add that functionality to our work, so that we don't have to recode all those things from scratch. Okay, so that was just a bit of terminology. Now let's come back to the Arduino program structure. So every Arduino program or sketch file should have at least 2 basic functions. Now, what is a function? What you see here from line 1 up to 3 and line 5 up to 7, we call them functions. Now, for now, I need you to just understand that they are called functions. Now, what functions are, we will look at it in the course of the lecture. Okay. Now, these things are very mandatory. That means you cannot decide that, hey, I am not going to have them. No, you need them for your Arduino to work. And these two are what we are talking about. So we have the setup and we have the loop. Okay. Like I said, they should always be present. You shouldn't change them as you see them. You should always write them like that. The braces, the void, the setup, the loop, the parentheses, you should make sure you are keeping them. Now, I know with time you would understand all these things, okay? So every Arduino code can be divided into 3 main parts. We have the structure, we have the values. So in terms of values, we'll be talking about variables and constant, and we have functions, which for, I just said that basically certain 2 functions at least should be present, which is your setup and your loop function. Now, let's look at what they do. Whenever you are using the Arduino, you first have to perform certain configurations. For instance, before you can use any digital pin, you need to tell Arduino whether you are going to use it for input or for output operations. Okay, and all these things are stuff that you need to configure before Arduino begins to execute your application. Is that okay? So any form of configuration activity, that is also to say that any code that is supposed to run just once and at the beginning of your program, you should always put them in the setup function. Okay, so case in point, if you look here, we have serial.begin 9600, which is establishing a serial communication between the Arduino and the computer so that it will make it possible for me to send data from between the Arduino and my computer. Okay, now this code needs to run once and at the beginning. Once it is done, it doesn't have to run again. So it is a form of configuration code. So I have to put it in my setup. Again, if you look on line 4, we have pin mode LED output. So this is telling Arduino that, hey, there is this pin I'm calling LED. It's actually assigned to a value 13. I want to use it as output. Okay, so that means Arduino knows that whenever you are using this, you are going to switch it on or off. It's just going to provide voltage. It's not going to be as an input. Okay, so these are things that you want to do at the beginning of your work. And just that. Okay, so every form of code that is forming part of configuration should always sit in the setup. Now, once the setup is completed, the rest of the code that needs to run over and over should sit in the loop function. Is that okay? So for instance, the program I just showed you, realize that the LED was blinking on and off, and it will do that. So I shut down the application. That code is always supposed to be in your loop. So your loop should hold the actual business logic for your application. Okay. Now, given that there is power connection to your Arduino, the loop is an infinite loop. That means it never ends. Okay, so anything in it will keep on running and running and running so far as the Arduino has power. Okay, so these are the things that the two functions which are always expected use for: the setup for configuration, loop for the execution of your actual program. Okay, now I did mention that we have values, and values can be in the form of variables or constant. Okay, so let's look at constant. When we say that something is constant, it means that it doesn't change. Okay, so the value is fixed. Now Arduino has some inbuilt constants that we'll be using a lot. Okay, and the ones that you'll be seeing most of the time, we have the logical level constants, which are the true or false. Okay, so true or false, these are constant values. Okay, then we have pin level constants, which are high or low. Now, technically, high is also true and low is false. Okay, so yeah, should understand that. Then we have what we call the pin mode constant. So there are 3 pin mode constants. That means we can always configure our pins in 3 different modes. The first is as input. Now, when you configure a pin as an input, it means that it will be listening for voltages, right? If you configure it as output, then it will be outputting, it will be sourcing voltage. Then we have the third, which is input pull up. That means you are setting it as an input, but with an initial state, which is high. Okay, that is what we mean by an input pull up. When you when you activate the input pull up, it means that you want to use that pin for input operations, but you need it to be a default high. Okay, so you usually do that when you are listening for active low signals. Okay, we will look at that. Then there is the built-in constant, which LED built-in. Now, this LED built-in is a value that is holding the number 13. So whenever you use LED built-in constant, it's just saying 13, right? And that 13 is there because there is an LED on your Arduino board. Let me see if I can show it in the picture. There is an LED on your Arduino board that is connected to somewhere about it. This particular small LED here is connected to pin 13, which makes it possible to do hello world programs with Arduino without connecting external components, right? So you can just run a blink command and let that LED blink. So to reference it, you can either use the number 13 or just say LED built in. And please, these are keywords, so you have to type them as they are. If they are caps, you have to put them in caps. If they are lowercase, you have to make sure they are lowercase. Okay, now if I give you the values, 1, or let's say the age of a person, the gender of a person, the name of a person, what can you say about this data point? Yes, come online. Tell me something. I think I should see your faces. As many as can show their face. We are getting into an interactive section. So if you can show your face, please show your face. Just put your mic on mute so that it doesn't disturb. So yeah, gender, age, and the name of a person. What can you say about these things? Yes, tell me something. Gender, age, name, they are all data, right? For instance, if you are going to make an ID card, these are information that will be taken, right? But what can you say about these 3 data points? Yes. Tell me something. Anyone? Okay.
Okay, I think they say something about the user.
They are
about like they identify, or they say something about the user.
About the user. Okay, thank you. Any other?
Yeah, okay. I was also gonna say the identity.
Okay, your network is very bad, so maybe just type it in there.
Of what you are talking about.
Okay, your network is very bad. I couldn't make you out, so just type it. We will read it later. Okay, all right. So
yeah, somebody in the chat, Elijah okay. Says that gender could be a character.
Okay, thank you. All right, so you realize that
age and integer.
Okay, so you realize that the age of a person is a number, right? And after every year, you would want to increase it by a factor of 1. Okay, now I can take somebody's age and guess how old the person would be in the next 5 years. Okay, and I can do mathematical operations on that. Now, let me see. Our Jemima, in the next 5 years, what will your name be? Can I multiply your name by 5? What will I get? Can I divide your name by 2? What will I get? You realize that depending on the kind of information, there are certain things that
you cannot do that.
Okay, thank you. Depending on the kind of information you have, there are certain things that you can or cannot do with that data. Okay, for instance, we said that we can add, we can multiply ages, we can divide them because they're numbers, but we can't divide date, names or gender and all those stuff, right? Okay, so every data that we want to manipulate in our Arduino program has a type, okay? Now, indirectly, this type also informs the computer about how much memory it should reserve to store that value, okay? So in computing terms, we call this data types. Data types. And data types do 2 particular things. 2 things. First, it tells the computer how much memory should be allocated to store that data. And 2, it also tells it what operations are possible with that data. Okay. Now, in the Arduino, the data types could be grouped under integral data types or integers, floating point data types, strings, and the compound or composite types. Okay. Now, let's look at these things. And please try to get these things, because the moment this goes, you don't get this concept, programming will be very difficult for you. Okay. All right. Then we also have void. Void technically is not a data type. It only means that emptiness, there is nothing. Okay. We will see about that, but it is not a data type on its own, but it can be used as a return type, which I'll explain when we talk about functions. Okay. So void is used for function declarations as a data type when nothing is supposed to be returned from that particular function. So if you look at our setup and loop, you see we have void setup, void loop. This means that these guys don't return anything once they are called, and I will explain what function calls are, so you grab the concept very well. Okay. Now, in the integer world, we have long. Now, a long under normal circumstances is supposed to be a 32-bit number. 32-bit number, that means it can store up to 2 raised to the power.
2 raised to the power 5.
32 bits. So 2 raised to the power 5.
5, yes.
Okay, and what is that supposed to be? Are you sure? No, it's not supposed to be 2 raised to the power 5. It's supposed to be more than that. So the way you do that is 2 raised to the power 32, okay, divided by 2 minus 1. Okay, so you can use your calculator to compute it. Now, if you do this, you realize that the maximum positive number would be, I think, 2 billion and something, which tells you that that is the maximum number a data type that has been declared as long can hold. The moment you exceed that number, Arduino or the program is going to enter into an erratic state or erratic mode. Okay. Then we also have a type called the word, which is a 16-bit type. We have a short, which is also a 16-bit. Now, because of memory constraints, most of these things don't actually have many variations on the Arduino platform. Okay, for instance, the short, the word, they are both 2-byte data types. Okay, 2 bytes, that means 16 bits, okay, data type. So, and even the integer, but on an actual computer or in actual C++, a short is typically about 2 bytes and an int is typically about 4 bytes, long is about 8 bytes, but those things are usually compiler dependent. But on the Arduino, most often you don't have any difference between that. Now, another case in point, so we use the word, the short, and the int for whole numbers or integers, numbers that don't have decimal places in them, okay? Then, anytime we want to represent numbers with decimal places, like the value of pi, 3.142, blah, 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 right? We want a data type that could hold that. And in Arduino world, we call it float. Now, sometimes you see double, but in Arduino, a float and a double has no difference. It's actually the same thing. But in an actual C++, float and double differ by what we call precision. Now, with precision, we mean the number of decimal places that they can have, okay? For floating point numbers, we are interested in precision. So for instance, if I give you a value of pi as 3.14, it is not as precise as 3.142. And 3.142 is not as precise as 3.125, blah, 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 okay? So the more the number of decimal places, the more precise that number becomes. And that is how floating point data types are differentiated. But like I said, in Arduino, whether you use float or you use double, you are actually working with 4 bytes and they don't actually have any difference. Now, a string is used whenever we have a sequence of characters. A character is anything on your keyboard. A number is a character, a comma is a character, punctuation signs are characters, the alphabet are characters. So whenever you want to put them together, so in order to spell somebody's name, in order to make a statement, you put characters together. So when you have data of this kind, then you have to store them as what? A string. So a string is a sequence of characters, okay? Or an array of characters. Now, there are 2 types of strings in Arduino. We have a string starting with the small string, okay, which is actually a character array. So those who know of an array, take it as a box that has segments, and inside them you put your character. So if I want to spell out professor, I'll have one segment containing the character P, another R, another O, another F, another E, another S, another I, and another R, okay? But this is just a character array. Then we have a string as a class, okay? Now, mostly you want to be working with string as a class because most of the manipulations you can do on a string, you can only do them on a string as a class, and I'll show you how to do that. So anytime you create a string with small s, you are creating a character array. Take note of that. Anytime you create a string with capital S, you are creating a class string, which is usually what you want to do, because when you create a class string, you can perform these kind of operations. For instance, you can compare whether it's equal to something, you can equal, ignore case, and a whole lot of other methods that you can call on them. Okay. Then we have what we call a car. Oh, let me mention that strings are delimited. When you are creating strings, we will look at it very soon. You put strings in double quotes. Okay, you always put strings in double quotes. If you want to tell the Arduino that this is a string, put it in double quote. Now, characters are single letters or numbers or punctuations or signs or whatever that could be. Okay. Now, characters are always delimited by single quotes. So on the Arduino platform, when you see something in a single quote, it's a character or a card. If you see something in a double quote, it is a string. So take note of that. Okay. Now, there are times where you want to be able to convert between one data type to another. For instance, you want to convert from an integer type to a character type, or vice versa, or from an integer to a float, or from float to integer, even from a string to a number and a number to string. Okay. Now, if you want to do this, we call it type casting or type conversion. Okay. Now, not all type conversions are possible. Okay. For instance, if you can, before you can convert a string to a number, that string has to have numeric characters. Okay. You can't convert that something that is like 12A to a number. No. If you, before it can happen, it should have the characters 1 and 2. Everything has to be numeric. Then we also have what we call type qualifiers. Now, I'm trying to talk about these things so that when we get into code, I can just move on and be using them, okay? We have type qualifiers, which are ways of tweaking the way these data types are used. Now, there are 3 of them. We have const, we have signed, and unsigned. Now, usually I've realized that most people find it difficult understanding these things. So please, if you have any challenges, just draw my attention. Now, const is used to make a variable constant. You are trying to tell the compiler that, hey, this value that I've set to this variable, make sure it changes under no circumstance. Okay, so the moment you want to give that instruction to the compiler, then you have to attach the qualifier const to your variable declaration, which I'll show you in a minute. Then we also have one called signed. By default, integers and floating point are signed. Signed means that they can be negative or positive. Is that okay? But then there are times where you want to ensure that, for instance, if I'm saving the age of people, there is no way somebody's age will be a negative number, unless probably you are called Solomon. If you are called Solomon, your age can be a negative number. But apart from that, usually all the normal folks will have positive ages. All the normal folks will have positive ages, right? So you would want to ensure that ages stay positive, and in the scenario where something or somebody tries to key in a negative number, you want the computer to realize it and throw an error. Okay, so in that case, you want to use unsigned, right? But by default, all the numbers are signed until say unsigned. Now, another beautiful thing happens. You see, the maximum value that a short or an integer can take is 32,758, if I am right. Okay, that means that if I try to set 35,000 to an integer variable, it's going to have an error is going to happen. Okay, so One way I can do that is to say that, hey, I want this variable to be unsigned. Now, if you use unsigned on an integer, for instance, it prevents it from having negative value. So it shifts it from the minimum negative value to start from 0. And in that case, also increase the upper positive bound. That means instead of ending at 32,000, it will now be ending around 64,000 something. Okay, so I'll demonstrate all this thing to you in code. Okay, all right. So that is where or how to use this qualifiers. Okay, now, anytime we are programming, we will need to store data. Okay, because the programming is mostly about manipulating some data. So we need a place in memory to store data. In order to store data, we need memory addresses. Okay, unfortunately, the way computers keep track of memory addresses is by using numbers, and you don't want to be keeping those numbers in your head, right? So programming, computer science comes up with this means of doing things in a way that is convenient, called variables, right? So instead of me keeping the addresses by numbers in my head, I assign them a name, and I rather, since it is easy to remember that name, anywhere I use that name, it actually references that value that I put in that. Okay, so for instance, technically, the right way of identifying any one of us is by our DNA sequence, right? So if I want to call Solo, for instance, I'll start codon, codon, anticodon, codon, codon, talk all about his DNA, because that is how he's uniquely identified. But just imagine, by the time you are done saying that, probably the word has ended, right? But when I say Solo, it embodies, it represents that particular person, and he responds, right? So in programming too, we have something called variables, which are named or allocated memory spaces. So we put a value somewhere in memory, and in order to remember that place that we stored our value, we assign it a name, okay? A very nice name that we can remember, okay? So that is variables, and we'll be looking at it. Now, at every point in time, variables could be in one of two scopes. The scope is where the variable can be found. Now, we have global scope and local scope. I will explain it and demonstrate it in code for you to know, but for now, just listen. When we say that the variable is in a global scope, it means that it is in a point in the code where no matter where you are in your code, you can have access to it. No matter where you are in the code, you can have access to it. When it's in a local scope, it means that it is bounded within a particular geographical coordinates, if I may put it. So for instance, let me show you something in the sketch that we use. You see, line 1, we said const, and here, so now that you know what const is, you should know why we are using it. So I want to say that, hey, I want to bind the number 13 to the name LED, and I don't want it to ever change. Now, because this is a number, I use a numeric data type int. So now you understand why we did what we have on number 1. Okay, so const is preventing that it can be changed. Int is because it is a number, and LED is the name that we have assigned to this value 13 in memory. And this is what we call a variable declaration. Now, because this variable has been declared outside of any braces, it makes it global. That means it's in the global scope. So you see that inside my setup function, I make reference to it, and inside my loop function, I also make reference to it, okay? And there wouldn't be any problem because this guy is in the global scope. But if I should move this into in between this parentheses, right, or between line 2 and 5, then I have put it in a local scope. I've localized it. In that case, if I try to run this program, it's going to give an error because this guy will not know where or what is called LED because I have moved it into a local scope. Okay. Please, if you have any questions, draw my attention. And I wish if questions come in all the time. Okay. So let's continue. All right, so that is scope, global and local. Okay. Now, one thing you should know is that you don't want to be creating many variables in global scope. It's a very bad programming habit. One, because on Arduino, yesterday we saw that when you are programming Arduino Uno, for instance, you only have 2 kilobytes of memory, right? Anytime you create a global variable, it will stay so far as the Arduino is running. It will remain in memory, okay? But when you create a local variable, so far as that scope gets out of memory, that memory is released back to the system so that the system can use it for something else, okay? So in as much as using global scopes are easy way, always try as much as possible to avoid it if there is a way to do the same thing using local scope, okay? Then there is something called static, which we can create something called static variables. But then right now, if I should explain static variables, you wouldn't understand. So I will move it to functions. When I'm talking about functions, then I'll talk about static variables. So remind me and put in your mind that when Prof talks about functions, is going to talk about static variables. Okay, then we also have volatile variables, which is also something I'll talk about very soon. For now, if I mention it, I don't think many of you would understand. So let's keep it this way. Okay, but yeah, maybe. Okay, I think I should talk about it when I need it. All right, so that brings us to the end of this particular section. So ladies and gentlemen, we are in for a treat. We are going to have fun all over, and thank God we have about 30 minutes to have fun. So let me bring up my
Yes,
Arduino.
Prof,
So
a little bit just before you begin that fun. I am very excited. I cannot wait. I'm waiting seriously. However, Elijah has a question, and we have to. He said, I am quite curious about the compound data type. Any insights on that?
Okay. Thank you very much. A compound data type is just a data type that's made up of many other fundamental data types. So we have fundamental data types. Example is the int, the char, the boolean, the float. Okay. Now, sometimes when you are working, you need something more sophisticated than these guys, right? So you define your own, and that's what we call structures. We have something called structs. We have something called unions. We have something called classes. Okay, so a string, the one with a capital S, is an example of a compound data type because within it there are other fundamental data types coming together to serve as one data type. Okay, so probably we will definitely use a struct. So that would be an easy way of showing you what a compound data type is here. Okay, any other questions? Any other questions? Any other questions? Yes. Okay, so let me clear everything here. We are going to build everything from scratch. Okay, so now I need you to pay attention. Okay, pay attention. Anytime you are writing code, make sure you don't put anything that can be removed from your code. That is to say that anything you put in your code, make sure it counts, okay? All right, so by default, I said that no matter what you want to do, so far as it is an Arduino source file or sketch you want to create, there are two things that you always need. The first one is the setup, and the second one is what? The loop. So let's go ahead. The signature is void, followed by the keyword setup in small letters, followed by parentheses. Please, you cannot decide not to bring this, okay? These are required. Then followed by braces, okay? So whatever we want to do in the setup has to live between these two braces. Is that okay? Now, what we are going to do, our first experiment is going to blink this LED here. Is that okay? Yesterday, we learned that when we use the Arduino as a digital output pin, it can provide a maximum voltage of what? 5 volts and a maximum current of 20 milliamps. So let's see, by connecting this LED here, an LED, blue color LED usually will drop around between 3 to 3.4 volts, okay? And so we can't hook it directly to the Arduino pin because the Arduino will give it 5 volts. That means it will burn out, right? So in order to deal with the excess voltage, we put a resistor here, and the resistance value is calculated so that it can deliver the current that we want. Now, in this case, let's assume we want 10 milliamps of current to flow through the LED. That is possible because then we know that the Arduino pin can supply 20. So if we only need 10, that is good news, right? Because yesterday I told you that you should never draw more than that current. Okay, so 10 milliamps is good. So we have to find a way of limiting it and also dealing with the extra voltage so that if, for instance, we are saying that 3 volts should drop across this blue LED, that means that we have an excess 2 volts to deal or to throw away. That is what we need this resistor for, to handle that excess so that this doesn't burn out. So in essence, this resistor is serving as a protective or a shield resistor, okay, dealing with the excess voltage. So if you look here, you can see that I have hooked it up to pin number 13, right? And we are going to use pin number 13 to be switching this on and off. So when we switch pin 13 on, what will happen is it will provide 5 volts, and that will drive current through this LED, and the LED will turn on. Then when we switch it off, it goes off. Is that okay? So how do we do that? First of all, before you can use any pin for digital operation, you have to let Arduino know your intention, right? And the way you configure pins is by using a function called pin mode. Now, anytime you use a pin mode, an Arduino function, inbuilt function, correct, it should highlight, okay, with this orange kind of color. Now, the pin mode function takes 2 arguments. The first one is the pin that you want to configure. And here, our circuitry is connected to pin number 13. So that is the first argument we will pass to this. Probably tomorrow we will look at how to create functions to understand these things well. Okay, so the first thing is the pin. Now, how do I want Arduino to treat this pin? I want it to treat this as an output pin. Okay, that means that this pin is going to source or provide voltage. It's going to what? Provide voltage. Going to provide voltage. Now, in C++ or in Arduino programming language, anytime you want to tell the compiler that, hey, I am done talking, just like in English, we will use full stop to terminate a statement. In C++, you use a semicolon. And once again, just like full stop is compulsory in English, semicolons are compulsory in Arduino program. Okay, so this tells the compiler that, hey, I want you to configure pin 13 as an output pin. Is that okay? So once I run this, it's going to put the pin in an output mode, which means it can switch on or off. Okay, so I'm done with my configuration. The next thing is the actual logic that I want to execute. And like I said initially, that is the thing, the code you put in your loop. Okay, so the loop has the signature, void loop in small letters, followed by the parenthesis and then the brace. Now, in the loop, anything you put in the loop will run over and over and over and over. Okay, so the first thing we want to do is to switch on this light. Now, since this light is controlled by the pin, that means we have to switch on the pin. So we have to tell Arduino to provide power or to put voltage on that pin. To do that, we use a function called digital write. Okay, digital write. Now, digital write also takes 2 arguments. The first one is the pin you want, the pin number that you want. Okay, and so here you can see that the pin numbers that I'm using maps directly to what you see on the Arduino board. Is that okay? So if our circuit was probably connected to pin 8, then I'll be using 8 instead of 13. Okay, and what state do you want the pin to be put? So since we've configured it as an output pin, we can put it on low or high. Right now, we want to put it on high. So remember the pin mode constants. We type capital H-I-G-H, high, okay? And this tells Arduino that put pin 13 on a high state. Now, when pin 13 is put on a high state, it means that it's going to drive this circuit with 5 volts. That means this LED will turn on. So ladies and gentlemen, let's save our work. I've already saved that. Give it a name, blah, blah, blah. Now, the moment you are done, you are not done here. This code, as we've written, resides on our computer. It is not on the Arduino yet. Is that okay? So the first thing you want to do is to check for errors, which in Arduino parlance, we say you verify your code. So I'm going to verify the code. When you verify the code, you see some compiler log outputs here. In case there is any error, it's going to prompt you for you to fix that error, okay? And you can see that my thing is done compiling and there are no errors, so that is good news. But even as at this point, the code is not on the Arduino yet. Is that okay? Now, if I were to be using a physical Arduino, to load this code to the Arduino, I have to do upload. Is that okay? But I'm not using a physical Arduino, so for this case, all I have to do is to verify. Now, you can also take a shortcut route by just using upload. When you use upload, it is going to do the compilation and the uploading together. Is that okay? But in the situation where I just run the verify, then it just goes straight to upload it, where it transfers what we call the hex file onto your Arduino. Okay, the hex file is, in other sense, the machine language version of the code that we've written. So what I have done has actually linked, and since I've linked this to my Arduino already, the connection is already there. So now let's see if I run this simulation, you see that the light turns on. Ladies and gentlemen, this is your first Hello World application on the Arduino platform. Any questions up to this point? Yeah, we still have 15 minutes. Any questions up to this point? Okay, so you see that if you have any question, you can always chip it. So you see that now the the LED is just on because that's the instruction that I've given it. So it will remain on no matter what. Even when I reset it, it will come back on. That's what all that it will do. Okay, all right. But you see, I use the number 13 here, and I use 13 over there. Okay. If I should proceed with this code, I'll keep using 13, 13, 13, 13. And assuming I need to change the pin from 13 and probably hook it to pin 12 like this, okay? So that the Arduino is, the LED is no more connected to pin 12. You see, in this case, if I run this code, it is not going to run because the pin that is in action is pin number 13, not pin number 12, right? So to get this to work, I'll have to come back to my code. So let me stop my simulation and change this to 12 and that also to 12. And now compile again. And if I run the code right now, everything will work just as fine, okay? So just imagine if I had to change this 1,200 times in the code. Anytime I want to change my pin, I have to go through my source code. That is a lot of work. So instead of doing that, we want to find a solution to that. And that is when variables, for instance, come in handy, okay? So instead of putting the number 12 throughout, we're going to save it to a name. We're going to give it a name so that anytime we can just use that name, okay? Now, the number 12 is the pin. Physically, that pin is connected to pin 12 and it is not going to change. So we don't also want a situation where something, some process or some expression will end up changing it. So we can use the qualifier const, okay? Now, it's a number that we are dealing with and it's an integer. So the data type that we will use will be int. Then what name do we want to call it? Now we can choose any name. You can call it Kofi, you can call it Solo, okay? But always choose the names and make it descriptive. Is that okay? So I'm going to use LED. Now you should take note, the names you choose cannot have certain things. There are rules. A name cannot begin with a number. For instance, I can't say 3 LED or because it is pin, so I say 12 LED. No, a name can never begin with a number, but it can continue apart from, it can end with a number. You can have a number anywhere, but it can, every name should always begin with what? A letter. Aside that, the only character I can't put like a hash or other characters in the variable name. The only character that is allowed is what we call an underscore. Okay, so I can say pin underscore 12 if that is how you want to call it. One thing else is you cannot have names in between your, you cannot have spaces in the name. For instance, you can't say LED space pin. No. So take note of this thing. If I want to say LED pin, I can write it together, LED pin, or I can say LED underscore pin, or we can use something that is used by the community called camel casing, LED pin, like that. Okay. So take note, the names are having some rules and regulations. So now I'm just going to call it pin. Okay. So I can do this. Now, what I've done here, we call it variable declaration. Sometimes when you are coding, you want to find a way of adding comments. You want to save a little bit of your thought on what you are trying to do. So for instance, here, I want to say that this is a variable declaration, okay? So you can do that by using what we call comment. Anytime you start something with 2 forward slashes, it's a comment. There are 2 ways of doing comment. We have what we call the inline or single line comment, which is delimited by double forward slashes, or there are situations where you want your comment to span more than 1 line. In that case, you use what we call multi-line comment. So you can say, hello, this is another line. Okay, so you can see that. So anything I'm typing, so far as is between this star forward slash and forward slash star remains what a comment, okay? Great. Now we call this multi-line comment because it allows you to write comments on more than 1 line. Now take note that this, apart from this star and this star, the rest of the stars are not necessary. You can ignore them. Okay. All right. So that's comment for you. So what we've done here tells the computer, the compiler, to give us some memory space. But as a standard, we haven't put any value in there, right? So we want to save the pin number, which in this case is number 12, to the space. So what we do next is say LED equals to 12. Now, this is what in programming we call assignment operation. Assignment operation. What we are doing is we are telling the computer to put this value into that memory space, or whenever we use LED, it should reference this particular value. Okay, so variable declaration, variable initialization. So initialization is the very first time we assign a value to our variable. However, if you meet lazy programmers like myself, we usually want to do this on 1 line. Okay, so we can fuse these 2 activities into constant LED equal to 12 and end it. Just as simple as that. So this, in this case, we have variable declaration and initialization all done in 1 statement. Whether you want to do this or that, everything is totally up to you. But trust me, eventually you would be doing this. So yeah, it's just about programming style. Okay. So now that we've defined a variable name for this, you see, I can just come in here and in place of my 12, put my LED. Now, remember I said that whenever you put a sequence of characters together, you put them in quotes. Now, this is an exceptional case because what we've put here, though it's a sequence of characters, It's a name we are assigning to something. So it's a variable. The moment we put this in quotes like this, we have written something different altogether, and we are not going to get what we want. Okay, so take note, anytime you are using variable names, you don't put them in quotes. Okay, so right now, if I upload, if I compile, sorry, and upload, let's assume we are using a physical board, and I run this code again, say run the program again. Okay, so you can see that everything is working as it is intended, right? But the beautiful thing here is that now if I want to change this back to 13, I don't have to come and change it throughout the source code. I just change it here and voila, everything is good. So if I change it here, that means physically I need to connect this guy here and delete this, okay? So save this, compile again, and take note, anytime you make changes to your source code, you have to recompile it, okay? Anytime you make changes. And if we run this again, everything works fine. Now, before we close, let's do a little bit of variation here. This LED standing, why am I having an error? What happened? All right, I think it's something I can ignore. Okay, you see, this is not actually an interesting application, right? The LED just turns on and never switches on. So let's switch it on. To switch it off, we repeat the digital write command, okay? LED again, this time we use low, okay? Like that, and that switches off. So technically, we are executing two codes now. The first one on line 8 switches it on. The second one on line 9 switches it off. So let's run this code again. And then check our application, run the simulation. Oops, now, you see these blue and red lines here shows you that the code is actually running, but we don't see the light turning on. Who can tell me what is happening and why? Yes, any tickets. Why is the LED not switching on even though we have a high command over here? Yes.
I think it's because from the little I know about programming, the compiler runs every single line at a go. So probably it is like, sorry, it runs the first line before the second line. And so like the first line is high and the second line is low. So it has seen low as the last command. So it just maintains everything as low.
Okay, but you still do believe that it is switching on, right?
Well, yes.
Okay.
And so there are some more answers in the chat.
Okay, so you can read them.
Yes. Yes. Abhishek says no delay between high and low. Elijah says it happens faster than we can see. And Ramford said it is because it's on and off at the same time.
Fantastic. Okay, so what is happening is that it's what we call optical illusion, okay? The human eye can see 30 frames per second, which actually translates to, I think, a maximum about 10 milliseconds or something. Yeah, I can check the calculation. Okay, so anytime something is changing at that fast rate, we can actually see. And this is a micro running at 8 megahertz, right? So technically, we can't even see the difference between the on state and the off state. So our eye sees everything as off because that becomes the dominant state, okay? But what I need you to understand is that the code is equally switching this on as and off at the same time, okay? It switches on, switches off, but we end up seeing everything as well as off. It's because of optical illusion, just the fact that our eyes can't see beyond a certain frequency, right? But if you get something that can actually see more than our eye, for instance, if you get a very high resolution camera or something, you should probably see some light in there. But as it stands, our eyes can see. So to avoid this, we have to let the switching happen so that when we switch on we let it delay a little bit before switching it off. To do that, Arduino gives you a function called the delay. Okay, now the delay takes the amount of time or the duration you want it to stay on in milliseconds. That is 1,000th of a second. So for instance, if I want to say it should delay for 1 second, then I'll put 1,000 in there. Okay, so if I put this delay there, it means that now it's going to switch on for and stay on for 1 second before switching off. But again, we are going to have another issue. So let's compile and run, and then we tackle that issue too. So right now we should see the light turn on, delay for 1 second before switching off. Okay, so let me restart my simulation. Okay, but then again, we are switching on, we are switching off, but we don't actually see the off state well. Now you can see that the light is actually blinking somehow, right? It's because of software latency and stuff. But if I should do this on an actual device, you shouldn't actually experience that, okay? Who can tell me why we see the light mostly on and not going off, even though we have an off command? We have just 1 minute, so let's run it. Yes, any tickets? Why
okay, there is a reply in the chat.
Okay.
Navid Krishna says there is no delay after low.
There is no delay. So you see, the LED turns on, stays on for 1 second, then immediately switch off and comes back on again. Okay, so again, optical illusion, our eyes is unable to make up for that frequency. So to get a proper blinking experience, then we should turn it on, make it stay on for some time, turn it off, make it stay off for some time. So now we introduce another delay over here, upload the code again. And, oh, sorry, an error. Upload our code again. And now we should see a blinking effect. So ladies and gentlemen, that is how you create a blinking effect in Arduino. Now, if you want to increase the frequency of the blink, all you have to do is to vary this number, make it very smaller. So if I make it 100, that means I want it to be blinking at a rate of, and they don't have to be the same. For instance, I can say that it should stay on for 50, 10 stay on for 100, just as you want it to be. And if we save and upload, okay, simulate, and you can see that now we have a different blinking rate. Thank you. I will end here. If you have any questions, we take it, else we continue and do more awesome things, God willing, tomorrow. Thank you.
Thank you so much, Prof. Thank you. We've had a lovely time. I myself, I have learned a lot. I don't think I would be able to have learned any of this in any YouTube video ever. Thank you so much, Professor. God bless you so much. I know we've learned a lot. There's been so much communication, so much interaction with our participants, and I am happy and I'm excited to see all of these good things happening here. If you have any questions about the competition, if you have any questions about Professor, if you want to link up with Professor, kindly contact us at cansatghana@gmail.com. cansatghana@gmail.com, CANSAT@gmail.com. Thank you very, very much. Solomon, do you have something to say? Anything we should do? Other than that, we will call, yes.
Yeah, so I'll just say that thanks to everybody who was able to join. Prof, of course, thank you so much. I just want to emphasize that we apologize for the earlier delay because of the link and also not being able to start as we want, because we know people joining from different parts of the country, and hence the time difference means that it may be too late for people, for example, in India. So guys, thank you so much. And I don't want to, I think, we just have 1 more minute. So I would just like to say that thank you so much again. Just to check, Ms. Jake here is Prof? Is Kingsley also here?
Still around.
Okay, so your network is not too clear, but okay, it's fine. So we are going to definitely upload the videos today. So by tomorrow you should have it there. And once I do that, I'm going to send you guys an email with a link to everybody so that you can access it. So yeah, I think that should be all. And see you guys tomorrow. So tomorrow is the final day. Yes.
Sorry, I came in late. I have a question concerning what Prof. The simulation he did using the Arduino IDE with reference to the Proteus. The initial simulation he did, after he compiled the results on the Arduino IDE, he copied the hex file to Proteus. But the other simulation he did not do that. I'd like to know why he didn't do that.
Okay, so thank you very much. So you see, the moment after doing it for the first time and connecting the link, the Arduino doesn't clear the hex file until you close it. So it is still there. You get it. So anytime I update it and rerun the simulation, it picks it automatically. So far as I haven't closed the Arduino program, the hex file will still remain at the same location. But if I should close everything, I'll have to really attach it. Yeah.
Okay. Thank you very much.
And just a quick one. The beginners, please, if you can learn how to do, you can do very cool things with the Proteus. Okay. So if you can learn how to use the Proteus, trust me, you will really enjoy it. And maybe I'll show you later how to download it. It's a paid software anyway, but you can talk behind the scenes to show you how you can get it. Okay.
Right. So thanks, Prof. Thank you so much. So I just want to say that without these real sponsors, we can't actually get to do what we are doing. You notice that there's a lot of information, and in some part of the world, you actually pay to get this. So just to emphasize that this competition together with this workshop is brought to you by Space Generation Advisory Council. Of course, also the World CanSat Rocketry Championship. We also have Erictronics, which is where Prof. Or Eric is from. We also have Academic City, University College. We also have Xavier Space Solutions. And then finally, we also have the Mars Moon Aeronautics Academy and Research Science, who have actually given sponsorships to the winning teams of the Ghana CanSat Rocketry Championship to come to their place and then learn stuff about space research. So yeah, I think that should be all for today, and see you guys tomorrow. I don't know if I missed anything, but if I did, Jake, you can add it. If not, then I can end the section.
Yeah, I think we are good.
Okay, all right. So stop recording.